So welcome to stream one and implementation of real-time fuzzy search. So do you know what fuzzy search is? No, it's a search where you not searching for exact items, you're looking for a similar one. You know, like when Google asks you, did you mean? So this is kind of like this. So some like to start with an agenda. I would like to start with a statement. So I believe that reading table data is not that different from reading a book. And hopefully you will get to see it a bit later on. But right now I would like to focus on our goal. So we're trying to implement a simple input form which consists of following parameters: name, surname, date of birth, which is an optional one, and the last one is an indicator whether we're doing a fuzzy search or a non-fuzzy search. Okay, so non-fuzzy search, we call it an exact search, exact match. We are producing an output of exactly matched persons. For example, if we search for Anna Mikulic, we expect to find all Anna Mikulics. But please note that even though this is an exact match search, we are ignoring diacritics here and here. Also, a person can have multiple names and surnames. Those names could be delimited by practically any kind of characters, for example, hyphens, spaces, multiple spaces, brackets, quotes, and so on. So we simply have to ignore those characters. We're listing all the sources that we found those persons in. And in case of a fuzzy match, we're also expanding our result set to persons we consider to be similar. Okay, for example, Lana Mikulin. We're adding an additional column named similarity, from which our customers can see how similar those results are. So it sounds very simple, but let's see why it is not. So these are our business challenges. First of all, this is a real-time search, so no data warehousing, no data cleaning. We can't have any data marts. So everything is real-time, and we cannot change the sources. The sources are as is. So even though we have a simple input form, we are conducting a very complex search algorithm, which you will get to see later on. We're also dealing with mixed alphabet data, various character sets, various characters, various languages, which is not that simple. Also, our data ranges from 1 million to 70 million rows, which places our application as medium-large. We're dealing with dirty and inconsistent data input. So we already mentioned diacritics, multiple person names, but also beware that our customers can enter data in various ways. For example, the German letter scharfes S could be written as is or as 2S. So we have to basically search for both variations. So it expands our search by a bit, for example, 50%. So our legacy sources, we have some legacy sources that we're also searching. They have some limitations on character input and length. And our database models are also not that perfect. So sometimes we are searching, we have one attribute that contains name and surname, and sometimes we have two separate ones. So we have to take that into consideration. And on top of everything, our search has to be fast, error-proof, and must support partial resulting. Okay. A few words about the business algorithm. It was designed by our clients in order to maximize hit ratio. I can't tell you much about it because it's a black box, and it should stay because, well, it's not only project specific, but it's not really relevant for you. But I would like you to notice that it happens between the period where we click the search button and before we actually start searching, okay? So this is kind of middleware, and the output of it is a set of candidates that we're actually searching for. So we're not searching for just one person, we are searching for 5. The worst case scenario here, the output of the black box could be up to 20. So worst case, we have 20 persons that we search in 11 sources, times 2 because each search iteration must be done in the original and the root equivalent. So after the initial shock, we start planning our solution. So these are the facts about our sources. They are split by technology here. So 5 Oracle, 5 DB2, and 1 web service. Web service is specific because it's the cause why we're doing grouping and sorting on application level. So we have mixed database application logic here. Everything looks good on Oracle side. Our majority data volume is located on Oracle. We have all the fuzzy search capabilities. However, we have some problems with DB2. We're not accessing data natively, so we are using database links, which is always kind of tricky, you know. And the interesting part here is, well, we have no fuzzy search capabilities on DB2. So how to do a fuzzy search on a, you know, incapable source. So that's the thing we're actually trying to solve here. And our solution was split into 4 stages. Stage number 1, collecting candidates. This is, you know, the black box, okay? So the next step is creating dynamic threads. We call them thread groups, which execute in parallel in order to speed up the search. They are executing searches, aka database procedures, which have to take into consideration the 2 passes, you know, for the non-fuzzy or a fuzzy search, and the second one is a transliterated search that we have seen. And the last stage is actually saving results into our database because we would like to do some data analysis for it a bit later, okay? And why do we call it a dynamic threading? We have actually created a mapping table which maps our sources to the thread groups. So we can manipulate the thread groups in real time. So in case of a non-fuzzy search, we actually have only 4 thread groups. Perhaps you would expect that we have 1 thread group for each of the source, so 11. But no, since we have limited resources on our connection pools. And the other thing is because some of the sources are so fast that we don't even have to create it in a separate thread. We can group some sources together, okay? So as you can see, our thread group number 4 is responsible for these 5 sources, and it executes only 3 procedures. So this is basically a black canvas. You can play with these combinations and see how it reflects your performance. So enough about theory, let's go on to the fuzziness. So fuzzy solution on Oracle is natively supported. We use the Oracle Text. Oracle Text is a completely analytic solution for document classification. Actually, we're not classifying any documents here, of course. We are just using all of its features. And some of the features natively supported. You will see alternative spelling, which is a really cool one. So when you enter a search word Miller, Oracle realizes that the U with an umlaut in German, the alternative spelling of it is the UE. So it searches for both variations without your intervention, which is really cool. The fuzzy match that we need is actually natively supported. So when you enter a keyword Hornatich, you can see some of the similar results here. Oracle Text, you can imagine this as a virtual XML column, which is added to your table. And it has some sections. So in this case, we have only 2 sections, name and surname. And Oracle Text really doesn't care if you search for Ana Horvatić or Horvatićana, because what you're actually trying to say is list me all documents that contain the keywords Ana and Horvatić, okay? So now we have a first feature, which is if our data input is corrupted and someone inputted Horvatić as the name and Ana as surname, we will also find it, which is really cool. In order to configure Oracle Text, you have to answer a few questions. For example, how are your documents being stored? What languages are you using? Would you like to use the alternative spelling? Would you like to ignore diacritics, and so on? Okay. Some of the other feature we are using is the keyword searching. So where you enter basically your inputs, Maria and Miller, and the person that is found is also the ones with the multiple names, which is also something that we need. The pattern matching works basically the same as the basic SQL. So we are listing all documents that contain the pattern HORV. So this is the result. And the last thing is the contextual querying. So Oracle Text is smart enough to deep dive into certain sections. So we can actually list only persons that contain the keyword Anna within the section name, okay, if that's something that we actually need. Okay, and with this use of base letter, we are ignoring the diacritics, which is actually something that we also need. Okay. Some of the alternatives on Oracle we could have used is, for example, Soundex. I know most of you have heard about it, but I personally don't prefer it because it's mainly a 4-character hash value for 2 words that sound alike in English, which is not really applicable for our region, and I'm not a personal fan of it. The alternative is the UTL match embedded package in Oracle, which contains 2 mathematical functions. One is the edit distance, Levenstein edit distance, and the other one is the jar of Winkler. And comparing them on a high level, because on a low level there's heavy mathematical calculations being used. So on a high level, you will see that jar of Winkler is best suited for short strings. And with the small changes in strings, for example, if we replace the ch with the c, you will see that the added distance falls more steeply, so it's not resistant to small changes in strings, okay? Now, why am I talking about this? Let's move on to the DB2 part. So the facts are, we have no fuzzy search capability on this source. We have some limitations that we have to take into consideration. We're accessing data using database links, which is always tricky because you have to make sure that your query executes on the remote server, and you can really influence it. But we realized that we could simulate the fuzzy functions by using Oracle functions on the rows coming from DB2. So we're natively writing code on Oracle, retrieving rows from DB2 and calculating the jar of Winkler, and filtering rows that have similarity greater than 0.92. So this really solves our problem of having no fuzzy search capability on DB2. However, do you see any problem here? Anyone? Okay. So for the sake of this presentation, imagine that this is one of our DB2 sources. A relatively thick book. It has about 5 million rows, let's say. So what really happens in the background is DB2 starts flooding Oracle with all of its rows, every single row from this book, and Oracle calculates jar of Winkler and filters rows that contain a similarity greater than 0.92. So while I'm talking this, our customer still waits for the application to respond, which is not really perfect. So we need to do something better. So can we read faster? Can we shrink this book? What do you think? So we came up with an idea that we don't have to calculate jar of Winkler for every single name coming from DB2 because it's not logical. We as humans know that, for example, Thomas Müller will never be similar to the name Ana Horvatic, right? Okay, so we don't need it. So we can actually, we call this part rationalization. So we're rationaling the number of rows that have to be calculated. So we eliminate unnecessary rows from DB2 by adding this kind of filter, but basically you can add any kind of filter. So we left only persons that have name equally matched to the input, or our surname starts with or ends with something, or our surname is equal, or our name starts with or ends with something. So in this simple approach, we are eliminating 99.7% of the rows. We have an effective early filtering. So our filter actually moved from the left to the right, okay? And now, instead of having this, okay, we have, well, this. So Oracle can deal with this more efficiently, faster, and, well, this is about 500 pages. tops. Okay. We just have to be aware of the false negatives, because if our filter is too strong, it will eliminate some names that perhaps are similar. So you have to tune it, but this is basically the concept. Okay. Okay, so our application now supports fuzziness, both on Oracle and DB2. What now? So we entered the testing phase, and you can test it in many ways. We started by inputting some manual entries, like most of you do, dummy, test, Mirko, Slavko. But we soon realized that this just wouldn't cut it, because you have to simulate some international names, data cleaning, inconsistent data, and so on. So we downloaded some open databases available online. The one we have contains about 60,000 famous persons from all around the world. For some reason, Severina is also in there. And it really helped us understand whether our logic was correct. And you can see that source also has problems the same as your database does. So this is really cool. And why not trying out the real life? Our project manager had this great idea. Since she didn't know the names coming from the open database, that she will input her family into our application. In fact, she inputted her whole family tree. And the results were astonishing. She found some critical bugs just by inputting her aunt, which changed both husbands and surnames. So it was kind of hilarious to see bug reports like, I can't find my aunt by her third husband's surname, but really, really cool, okay? And the final stage is performance testing. So from a technical aspect, you have to make sure that your procedures perform well. And you can do it in several ways. For a single user test, we have actually developed our own custom tool, which does exactly that. So it picks up a database object, and you can point it to a certain source, for example, this. And it does about a couple 100,000 iterations, executes it, and outputs the basic statistics. And you can deep dive into a certain peak and say, okay, I would like to see which parameters we used. So you can tune your queries. For a multi-user test, we used the Apache's JMeter, which is really effective in simulating your real-life scenario where multiple users are clicking, and you can see how your application deals with this efficiently. And the last thing, since we are storing data into our database result, we can do some real-time quality check reports and see how our application is actually doing in real time. These are actually the real numbers. So you can see our non-fuzzy search takes about 2 seconds, and our fuzzy search about 2.5 to 3. So we consider this to be real good numbers, considering all the sources and various database types. So should you have any questions or comments, now would be the time. If you're too shy to ask, we can probably dim some lights or something. Mm-hmm. Well, that's a very good question. However, the DB2 doesn't have this function, so we couldn't use it. Yeah.
Okay, but I mean, you can implement a function on DB2 in Java or in something.
Yes, we could, but it would take a lot of time, and we are not sure about the results, So we had no influence on the DB2 as a source, so we would have to contact some external vendors. It just wouldn't be applicable to what we are trying to do on this project. So basically, yes, it is a good idea to move the filter to the source as we did, but fortunately, it wasn't really applicable at this time.
Okay, thanks. One other question. I
Yeah.
saw you mentioned the Oracle text. Do you know, does it support stemming in Croatian?
Stemming in Croatian, it should, yeah. Yeah, it should.
Okay, thanks.
Did you explore any other database, like exporting it to Elasticsearch or anything like that?
No, no, it didn't. That's it. Thank you so much.